Hello, everybody. Continuing on with rational functions, we got a good one today. So here is an example from your homework, Delta Math, and you're supposed to plot this. Looking at this graph, look at this rational function right away. The denominator's degree is bigger than the numerator's degree, so that means it does have a horizontal asymptote, or horizontal asymptote of y equals 0. Whenever the degree in the bottom is bigger than the degree in the top, you've got a horizontal asymptote of y equals 0. A y-intercept, if you plug in 0 for x, well, the top would become 12, but the bottom would become 0. So plugging in 0 for x leaves you with an undefined value. So that means there is no y-intercept. This graph will never hit the y-axis. And moving on from here, it's probably best to just factor this. The numerator factors, there's a GCF. I could take out a 3 or a -3. I'll take out a -3 because looking at the denominator, I've got a x minus 4, it looks like in there. So I'll take out a -3 from both of these terms, and I'm left with positive 1x minus 4. The denominator has a GCF as well of x. I take that out. I'm left with x minus 4. And these two x minus 4s cancel out. That tells me that there's a hole when x equals 4. And when I plug in 4 into the remaining, the diluted version of the function, I would get -3/4. So this is exactly where the hole is at 4 comma -3/4. But what about x? When x is 0, I am dividing by 0 still. So that means that's a vertical asymptote. It did not get canceled out. So from the top, there are 2 points of discontinuity, 0 and 4. The x value 4 actually gets canceled out. So that means the x value of 4 is a hole, still a point of discontinuity, but a hole. The 0 that didn't get canceled out is now a vertical asymptote. So back to my graph. I know there's a vertical asymptote at, well, this says x equals 9, x equals 7. It's at x equals 0. And there was no y-intercept. There was a hole at 4 comma -3/4. So I'm going to do my best to estimate where -3/4 is. Delta Math is pretty forgiving. X-intercept, is there an x value that makes the numerator 0? No, the numerator is -3. There is no x value that makes -3 0. -3 is just going to be -3. Way over here, if x is 4, then the numerator is 0. You see this? If x is 4, the numerator is 0. But remember, 4 can't be an x-intercept because 4 was the hole. So after the decompressed or the reduced version of this function, you have a vertical asymptote at x equals 0, and you have no x-intercept. There's no x value that would make the numerator, the top, 0. So there is no x-intercept, there's no y-intercept. I've got 2 asymptotes, so my graph is going to be guided by these 2 asymptotes. Looks like it's going to go through this hole, but remember there's going to be a empty ordered pair right there. And based on these 5 things, I can only graph 3 of them. And I just press plot rational function, and it fills it in for me. Submit my answer, cross my fingers, and yes, I got it. Today we're continuing with rational functions, but we're kind of moving backwards. If I give you the graph, can you come up with a function? This is a great exercise. Great exercise. And after we do the first one, you should pause the next 3 and try to do it on your own before you get the solution. So here's a rational function that is graphed. And what do you notice? Hopefully a few things. Number 1, we can say that there is a vertical asymptote at x equals 5. For sure, there's a vertical asymptote right here. That tells me that x minus 5 is going to be in the denominator, right? Because that's a point of discontinuity. And it won't be in the numerator because it won't cancel out. Only holes will cancel out. What else do I know? Well, I can see there's a horizontal asymptote at y equals 0. What does that tell me? Well, if there's a horizontal asymptote at y equals 0, then I know the degree of the bottom has got to be bigger than the degree of the top. What else do I know? Well, I have a hole right there, a removable point. At -1, the x value is -1. I don't know what the y value is, so I just put in a question mark. I don't know what it is. But I know there's a hole right there when x is -1. That means x plus 1 must be in the denominator because, remember, -1 would make you divide by 0. But since it's a removable point, it must get canceled out. So it must also be in the numerator. Now, this is, what do I have right here? This function that I have so far. My degree in the numerator is a first degree. The degree in the bottom is a second degree. So that would give me a horizontal asymptote of y equals 0. And just to be extra careful, I notice that f of 6 equals 1. So if I plug in 6 into these x values, do I actually get 1? And yes, you do. Hopefully you can see that without writing it down. But first of all, this 6 plus 1, which is 7. And this is 6 plus 1, which is 7. So those two 7s cancel out, leaving you with 1 in the numerator. And then in the bottom, the denominator, you have 6 minus 5, which is 1. So 1 divided by 1 is 1. This is the final correct answer. Kaboom. So that's pretty powerful. You saw a graph and you came up with the function that generated that graph. Let's practice again. Here's another rational function. This one's way funkier than the first one. What do you notice? Well, first of all, pause and see if you can see how far you can get on your own. There are two vertical asymptotes, one at x equals -5 and the other one at x equals 4. So that means that x minus 4 and x plus 5 are in the denominator because they make me divide by 0. There are no removable points, so there's no other factor in the denominator. But what else is there? What's this green one? F of 7 looks like it's 4. There's nothing special about x equaling 7. I just kind of scanned the purple function and tried to look for an ordered pair that were two integers. So it looks like f of 7 equals 4 over 7 up 4. So I had to make sure this is true. Whatever my final answer is, when I plug in 7, I have to end up with 4. There is a horizontal asymptote at y equals 3. What does that tell you? If there's a horizontal asymptote at y equals 3, then the degree of the top has to equal the degree of the bottom, and the leading coefficients have to divide to 3. That's what that means. If there's a horizontal asymptote at y equals 3, then the degree of the top has to be the same as the degree of the bottom, and their leading coefficients have to divide to 3. Well, right away, I've got I have a degree 2 in the denominator, so I've got to have a degree 2 up here. So I need more information. How do I get a degree 2 up here? Well, I've got one more clue. There looks to be a 0 right here. It looks like when x is 0, you're hitting the y-axis. So it looks like 0 is an x-intercept. That means that x is in the numerator. Let's just pause here and think about this function, the way this function is right now. If you let x equal 0, you would have 0 divided by -4 times 5, which is -20. So what's 0 divided by -20? It's, of course, 0. So right now, this looks like a decent answer, but something's wrong. I have the two vertical asymptotes. I have my x-intercept right here, but I don't have this horizontal asymptote. As it stands right now, the numerator is a first degree, the denominator is a second degree. So this function right here would have a horizontal asymptote of y equals 0, and I need it to be y equals 3. So I need both of these two degrees to be the same, and I need it so that when I divide the leading coefficients, I get 3 over 1. Well, this takes a little thinking outside of the box, I think, but once you see it, it's easier to see it the second time. I can change that numerator to this. First of all, I haven't added any more x-intercepts. The x-intercept is 0. It just happens to be occurring twice because it's x squared. And I multiplied it by 3. That doesn't change the x-intercept. It doesn't change the vertical asymptotes because 3 times 0 is still 0. But what it does change is it has the degrees of the top and the bottom are both squared. They're both second degree. And when you divide the leading coefficients, you get 3 over 1. So you would have a horizontal asymptote of y equals 3. So that's how we construct these rational functions. This is my best guess so far. Remember that when you plug in 7, you have to get 4. Let's see. If I plug in 7 into this, 3 times 7 squared divided by 12 times 3, you get 4.083, which is definitely close enough. 4.083 is close enough to 4, so that would be absolutely full credit here. As long as your work is supporting this. If you just put this out there with no explanation of how you got this, that's not good. 2 more examples, I think. So let's pause this one and please try to construct this one on your own. Well, what do you notice here? First of all, it doesn't look like the first 2 examples. There's no asymptotes, right? There's no vertical asymptote and there's no horizontal asymptote. So if there's no vertical asymptote, that means you're not dividing by anything that would make you have 0. That would last. And there's no horizontal asymptote. So what does that mean? If there's no horizontal asymptote, that means the degree of the top has to be bigger than the degree of the bottom. You probably noticed the holes early on. There are 2 removable points, one at 0, 7, it looks like, and the other one looks like 0, 4. Or I'm sorry, 5, 4. Well, that means when x is 0 and when x is 5, that's a point of discontinuity. So those are 2 divisions by 0. So this would go in your denominator. When x is 0, this whole thing would be 0. And when x is 5, the whole denominator would be 0. So those are 2 points of discontinuity. But because they are holes, they have to cancel out. So you need the same up here. All right. What else is there? Did you notice that this is just this blue thing? This is an algebra 1 thing. This just looks like a line, doesn't it? A line that would have a y-intercept of 7 if it wasn't for that hole right there, and a slope of what? 1, 2, 3, 1, 2, 3, 4, 5, -3/5. So this really looks like a line of -3/5 x plus 7. And if you carry this line outward, you would have an x-intercept right there. The x-intercept would be whenever y equals 0 in solving for x here. So -3/5 x plus 7 would go in the numerator. And last thing to check here, pick an ordered pair to see if our guess is correct. It looks like f of 10 equals 1. So if I plug in 10 into x here, I want to hope to get 1. So let's see. When I plug in 10, first of all, look at the x and the x minus 5. They all both cancel out. So you're just left with -3/5 times 10, which is -30 divided by 5, which is -6. And -6 plus 7 is 1. So f of 10 does equal 1. Notice I kind of went over this quickly, but this is the equation of the line. It's a matter of, do you put it in the top or the bottom? Well, realize we can't put it in the bottom because that would add another point of discontinuity. That would mean there would be some vertical asymptote somewhere. It goes in the numerator because also realize that when you're faced with this rational function, any one of you would cancel out these x's and cancel out the x minus 5s, and you would just be left with y equals -3/5 x plus 7. Which is what this line is. But y equals -3/5 x plus 7 with these other things attached to it is this line, but with these 2 holes. That one was a little bit unusual. All right. Last one. I thought I had 2 more, but this is just the last one. We have this rational function. There's a lot going on, and we have a little bit of a help. we are told that there are zeros at negative 0.8 and 5. What do you notice first? I always notice these vertical asymptotes. So I see two vertical asymptotes, one at x equals negative 2 and one when x equals 4. So that means x plus 2 and x minus 4 are going to be in the denominator. What else do we notice? There is a horizontal asymptote of y equals negative 5. So a horizontal asymptote at negative 5 means that the degree of the top and the bottom have to be the same. And when you divide the leading coefficients, you get negative 5. What else is there? Well, there happens to be a hole. Oh, let me try to clean this up. Okay. There is a hole when x equals negative 10. I don't know what the y value is, so I just put a question mark right there. But since there's a hole when x is negative 10, then I know that x plus 10 will be in the numerator and the denominator. So there's a lot of information here. Two vertical asymptotes, so I know these two factors are in the denominator. A hole at negative 10, so x plus 10 is also in the denominator, but x plus 10 is also in the numerator. And I have two zeros at negative 0.8 and 5. So that means that x plus 0.8 and x minus 5 are in the numerator. Remember, the numerator tells you where the zeros are. So combining all of that information into one fraction, you would get this. You have, look at your denominator, you've got 3 points of discontinuity, negative 10, negative 2, positive 4. The negative 10s would cancel out. That justifies the hole right there. The negative 2 and the 4 don't cancel out, so that tells you your vertical asymptotes. And these two other factors up here that weren't touched, when x is negative 0.8, this would become 0. That signifies this x-intercept. And when x is 5, this becomes 0. And that relates to this x-intercept. So there's a lot of stuff going on here, and this is where we are right now. But remember, there's a horizontal asymptote at y equals negative 5. As it stands right now, I've got a third degree in the numerator and a third degree in the denominator. So that means there's a horizontal asymptote wherever the leading coefficients divide out to. Well, if I were to multiply this all out, my leading coefficient would be 1x cubed. If I were to multiply the whole bottom out, my leading term, my first term, would be 1x cubed. So 1 divided by 1 would be 1. So and the way this is, you would have a horizontal asymptote of y equals 1. And I don't have that. I have a horizontal asymptote of y equals negative 5. So how do you continue from here? Well, remember, 0.8 is the same thing as 4/5. So I can actually rewrite that as 5x plus 4. If 5x plus 4 is also another possible factor, what I really did was I just multiplied both of these by 5. Multiply x by 5, multiply 0.8 by 5, 5x, and then 0.8 times 5 gives you just 4. So 5x plus 4 is a factor that if you plug in negative 0.8, you would get 0. And then I also slapped on a negative because now when I multiply the top out, my leading coefficient would be negative 5. And in the bottom, my leading coefficient would be positive 1. And now negative 5 divided by 1 equals negative 5. And adding a negative, or I could even multiply this top by 17 if I wanted to. It wouldn't change any of the things that I've talked about so far. I would still have the vertical asymptotes. I would still have this hole. I would still have these zeros right here, because when I multiply the top by 17, 17 times 0 is still 0. The only thing that would change would be a vertical stretch of 17. It would also change the horizontal asymptote. But here I've made some progress here. The horizontal asymptote is y equals negative 5. And finally, I need to pick an ordered pair, and I just chose 11 at random. When x is 11, it looks like the result is -4. So here is my best guess. If I plug in 11 into x, do I get -4? And whoops. Here's this function, but just with 11 being plugged in for x, and you get -3.89, which is definitely close enough. In fact, it was really just a guess. I was guessing just by looking that when x is 11, y is 4, but I'm only human, and maybe it's not -4, maybe it's -0.389. But this would be full credit if you show all this work and coming up with this function. 100% full credit. Come on. Let's investigate really quick. Let's go to Desmos. Just for a few minutes. Okay, first of all, 1 divided by x. So hopefully not a surprise. We've got a vertical asymptote at 0. If I change that x to -4, you could think of it as two ways. You could think of it as shifting to the right 4, because that's the transformation that happened. But also 4 now is the number that makes you divide by 0. So that is the vertical asymptote. And look at the horizontal asymptote, y equals 0. If on the top I put, x plus 5, then now the numerator and the denominator have the same degree. So they have a horizontal asymptote of whatever 1 divided by 1 is, which is 1. So I've got a horizontal asymptote of y equals 1. And then also, what makes this numerator 0? What makes x plus 5 0? -5 does. So whatever goes in the top, that's your x-intercept. I can, and if I change that x plus 5 to x plus 2, then I'm going to have an x-intercept right there at -2. If let's say I multiply by 13. Notice, you still have an x-intercept of -2. You still have a vertical asymptote at x equals 4. Just all multiplying by 13 was just vertically stretched everything. And look at your horizontal asymptote. The leading coefficient is 13x, and the leading coefficient down here is 1x, and 13 divided by 1 gives you a horizontal asymptote of y equals 13. All right, let's keep on playing. Let's put a removable point here. Or I can add another, let's see here. If I add another factor to the bottom, that's going to do two things. It's going to add another vertical asymptote, and it's going to change the horizontal asymptote. Because if I add another factor, like another x value, then the degree would be a second degree down here, making it bigger than the one up here. So that would have a horizontal asymptote now. Let's do x plus 1. So now I've got two vertical asymptotes at -1 and at 4. And you can add another. Let's say I want another vertical asymptote at -5 right here. So I would just type in x plus 5. I've got a vertical asymptote at -5, a vertical asymptote at -1, a vertical asymptote at 4. That looks pretty, but I'm going to get rid of that third vertical asymptote. Let's put in a removable point. Let's see here. Notice there's only one 0, -2. Let's add another 0. Let's have a 0 be at -6 right there. So how do I get a 0 right here? Right now, as it stands, -6 produces -0.08. But I want -6 to produce 0. So how would I do that? You would go to the numerator and type in x plus 6. Now look at the numerator. There are two things that equals 0. One is -2, and the other one is -6. And you still have a vertical asymptote at x equals -1. You still have a vertical asymptote at x equals 4. And what's your horizontal asymptote right now? It's y equals 1, because now the degrees, the top and the bottom, are both the same. So you divide the two leading coefficients. Let's change these. Okay, let's keep those vertical asymptotes. Let's get rid of that second zero that I put in there. Again, let's say I want a zero at 0. So I would just type in x. And when x is 0, you're at 0. When x is -2, you're at 0. Let's say I want a 0 at 3. So I would type in what? X minus 3. Still got the 0 at -2 for this one. And now I have a 0 at 3 for this one. But I keep on talking about a removable point, or at least I think I am. I know I've said it in my head a few times, but let's put in a removable point and then we'll leave. Let's have a removable point at 3. So that means I need x minus 3 in the numerator and x minus 3 in the denominator so that they would cancel out. And realize what that did, guys. I had to add another factor in the denominator. So now my denominator is a third degree. My numerator is the second degree, so my denominator is heavier. So now my horizontal asymptote is down again to y equals 0. I still have a 0 at -2. I almost said I have a 0 at 3. See, look at the graph. When x is 3, it's not a 0. Even though it's in the numerator, remember, it canceled out. So that means when x is 3, there is a hole. And where is it? We're right there. When x is 3, there is a hole. You are completely undefined right there. I hope that was beneficial. And we'll probably spend another day constructing these rational graphs and practicing them more. But please let me know when there are questions.